Welcome back. In this video we're going to turn our attention to the oxidation of a metal, and we can see that a metal can be oxidized, or remember that is having electrons stolen from it so that it becomes more positive, like a cation, and you can do this by acids and you can do this also by metallic salts. When this happens, this is called a single displacement reaction. It's similar to the school dance where you're there with your date and a more good-looking guy comes in and your date leaves with him. It's the sad story that we all share. So it is a single displacement reaction where you have a metal that's coming in that's more reactive than the cation of the salt, and so it's going to switch places with it. What's actually happening is that electrons are being switched in an oxidation redox reaction. So let's get started. The general pattern for both acids oxidizing metals and salts oxidizing metals is where you have A, this is what's kicking out B. So B is a metallic salt or an acid, and A is a metal, and A is going to kick out the cation and become the cation. So that means it's going to move from an oxidation state of 0, where it's normal, to an oxidation state that's positive. So it is going to lose electrons or have electrons stolen from it in a general pattern. So here's our first example. Here's one where metals are oxidized by an acid. Remember, acids always have hydrogen as the cation. You have cation is hydrogen, and then the anion is on the back side of hydrogen. So if hydrogen is the originally in the compound and it gets kicked out, then it is so reactive that it reacts with itself, and hydrogen with itself is hydrogen gas, and so you're going to get hydrogen gas bubbles come out. And you're going to see this a lot. If you have a metal and you're going to put that metal in an acid, you're going to get bubbles a lot. And the bubbles are hydrogen, and the hydrogen is from the acid. It's from the cation of the acid. So here's an example. We have magnesium. This is a balanced reaction. Magnesium is put into hydrochloric acid. So magnesium is solid magnesium metal. Hydrochloric acid, remember, breaks apart. It breaks apart into hydrogen and chlorine. Okay, so we have, here's the net reaction. You have magnesium, which has an oxidation number of 0. You have 2 hydrogen ions plus, 2 chlorine minus, and then it's going to, the magnesium is going to be oxidized. So 2 electrons are going to be stolen from the magnesium, and it's going to become positive 2. The chlorine in this case are spectator ions. They're exactly the same, and the hydrogen is going to be reduced. So it's positive, it becomes reduced. It's now goes from positive 1 each to 0. So you're going to have a reduction there. So here's what's happening. The magnesium is losing 2 electrons. The hydrogens are accepting those electrons. So the magnesium is being oxidized and the hydrogen is being reduced, and you end up with hydrogen gas that bubbles away. So let's look at another one. Here is one by a salt. You see here in this salt that the nitrate is on both sides. That's a spectator ion. So the net reaction is going to be iron plus nickel cation, and then you end up with an iron cation and pure nickel. So what's happening is that 2 electrons are jumping from the iron to the nickel. It's being stolen, so the iron is being oxidized, the nickel is being reduced, and then as a result you'll end up with an iron cation and then nickel metal. You have to remember that whenever one substance is oxidized, the other is always being reduced. It's the baseball player, it's the baseball pitcher, the baseball catcher. One is reducing the other and becoming oxidized. The other one is oxidizing the other and becoming reduced. So I hope this helps. Watch it as much as you need to, and ask me in class.